Hi guys, it's Mrs. Cameron here. We are on CLT math practice test number 3, taking a look um, at some test prep for your upcoming CLT exam. Number 87 says a wooden block is in the shape of a cube. Each face of the cube is divided into 4 identical squares. And all of these squares are painted either red or green. If each face of the cube must have at least one square of each color, what is the greatest number of green squares that can be painted? So we've got a cube. So all the sides are the same, that's fine. And each face of the cube is divided into 4 identical squares. So we've got squares divided into 4 identical squares. So each face, this happens, right? All of the squares are painted either red or green. Each face of the cube must have at least one square of each color. What is the greatest number of green squares? So what's the most I can paint green on one of these? I can paint 1, 2, 3, and have the last one to be red. And how many faces are on my cube, right? I got a top and a bottom, a side and a side, and I got a front and a back. So I have 3 green squares times the number of faces on a cube. And think of a cube. What's that the shape of? Like a dice. How many numbers on a dice? We got 6 faces, so 3 times 6. Our answer is 18. And then question number 87. No, that was number 87. Question number 88 says a student volunteers to participate in a psychology experiment. Participants in the study are randomly sorted into one of 5 equally sized groups. 2 of the groups need to take a survey, and the other groups do not. What is the probability that the student will be assigned to one of the groups that must complete a survey? So when we see that word probability or chance, we're going to set up our ratio or proportion by figuring out what we want, which is must complete survey compared to the total groups. Right? They didn't say ratio against non-competing groups, but the total groups. So how many groups must complete the survey? It was 2. And how many total groups are there? 5 equally sized groups, so 2/5. And then to turn our fraction into a percent, we need to write our fraction as an equivalent fraction with a denominator of 100, and our percent will be the numerator. So how do we turn 5 into 100? That would be 5 times 20. Maybe you remember that from one of the questions up above. Or maybe you just already knew that. And then if we multiplied the bottom times 20, if we multiplied the denominator times 20, then for the numerator or the top, we have to do the same thing. So we're going to multiply by 20 again. And 2 times 20 is 40. So there is a 40% chance that a student will be assigned to one of the groups that must complete a survey. We can keep moving on to number 89. Which of the following lines is parallel to the line passing through the points 1, 1 and 3, 5 in the XY coordinate plane? So we are looking for a parallel line. And what do we know about parallel lines on a coordinate plane? The most important thing from algebra or geometry class is that they have the same slopes. So I can find a slope between these 2 points, either by graphing it and counting the slope. One point is at 1, 1, so right 1, up 1 point. The other point is at 3, 5, so right 3, up 5, 2, 3, 4, 5. And between our 2 points, we are going up 1, 2, 3, 4, and over 1, 2. And 4 divided by 2 is 2. So we need an equation that has a slope of, not -2, we want +2 because we're going up. Negatives are out. Your slope is only 1. Your slope is 2. If graphing is not your strong suit or you're not quick at that and you'd rather use the formula way, you would say your change in y over your change in x, right? y2 minus y1 over x2 minus x1, which would be your y coordinates 5 minus 1 over, I started with the back one, so I'm going to start with the back one again, 3 minus 1 for the x coordinates equals 4 over 2. Every fraction's a division problem, so we got the same answer. Question number 90 says the area inside a track can be divided into a rectangle and 2 semicircles, as shown below. What is the area bounded by the track? Note, the figure is not necessarily drawn to scale. So I want the area of this shape, right? First of all, in the middle, I see a rectangle. And I know the area of a rectangle, actually it's given to you on the reference sheet. And the area of a rectangle is either length times width or base times height, however you want to call it. And they gave us our base and our height, which is 20 times 100. And 20 times 100 would be 2,000. So the area of our rectangle shape is 2,000. And now we need to take this area and add it to the area of the edges. So if I took my 2 semicircles and smushed them together, I'd have one whole circle, right? So if I took, my 2 semicircles and smushed them together, I'd have one circle. And my formula for area of a circle is actually the first thing on the reference sheet. Area of a circle is pi r squared, where r is the radius, and our radius of our circle goes halfway across. I know all the way across is 20, so halfway across my circle is 10. Area equals pi times 10 squared. 10 squared is 100, equals 100 pi. So each side would be 50 pi. So our answer would be 2,000 plus 100 pi right here at C. And question number 91, I think I can get in real quick before my timer runs up. Which of the following expressions has the greatest value? What do you call those straight lines outside of your numbers? Those straight lines are called absolute value. VALUE, my bad. And absolute value means your distance from zero. So when I'm looking at this, I'm going to treat my absolute value signs like parentheses. And then if I get a negative inside of my absolute value, like right here, that's negative 14, I'm just going to turn it positive because it's 14 units away from zero. So A would be 14 minus 4, right? Equals 10. Notice I kept my minus sign there, right? Not everything goes positive mode with an absolute value because that minus was not inside of the absolute value sign. So that one's 10. Part B, negative 14 minus 10 would be the absolute value of negative 14, which would be positive 14. C would just be 14 minus 10. And D, again, 14 minus 10, the greatest value would be at B. And I'm going to go ahead and see real quick how much time I have. 3 minutes. Number 92 real quick. Which of the following is equivalent to 2x plus 3 squared? In my class, the way we like to look at these is by making the area model, or some people call this the multiplication box method. 2x positive 3, 2x positive 3, and then we multiply them. You might use FOIL or something else, but my class, this has kind of been our go-to this year. So 2x times 2x be 4x squared. 2x times 3 be 6x. Again, 2x times 3, 6x, and 3 times 3 is 9. So we got our 4x squared, not 2x squared. And then 6x plus 6x makes 12x plus 9. Our answer is A. I hope you found this helpful, and I will see you on the next one.